All right, so today, Taylor Swift's concert promoter, we are investigating this, wants to find out how much fans enjoy the concerts. He's going to ask fans from 1 to 100, where 100 is the most, how much did you enjoy the concert? The section he wants to survey has 50 seats, 5 rows and 10 columns, looks just like this. The stage runs along the northern end of the venue where Taylor is pictured. He wants to take a sample of 10 seats. How can we go about getting a simple random sample out of these 50? How can we do a simple random sample? Yes. Super close. I like that one. I like a lot of what you said, except I'm questioning the 1 through 10. Why 1 through 10?
Because that's the
We want to take a simple random sample from this whole section. 1 through 50. Okay, so I want you guys to go ahead and do that. Nope. Or yes, where you're going to do a simple or a random number generator 10 times. Absolutely. So yeah, number them. Label your seats 1 to 50. Yeah, like write them down so that when you have that random number generator, you know which seat you're going to sample. So I want you guys to do that. Do a random sample of 10 and mark which seats those are. If it happens to give you a repeat, just ignore that repeat and move on. Mark which seats get chosen. Whenever we do a simple random sample, we have to follow the same steps each and every time. We have to label all of the individuals that are possible to be chosen. Then we have to randomize. You could write it on slips of paper, or we're using a random number generator. And then you are going to select. Do you guys remember how to get to the random number generator, like on your phone?
Yeah.
Okay. If anybody needs any help, please let me know. You need 10 seats selected. Yes. 10 seats need to be selected. Quick show of hands if you're done picking out your 10 using the random number generator. All right, I'm gonna wait just a couple more minutes then.
So it's like you mean like repeat, like just in general?
Yeah, like
It's
if
not
it gives
back
you
to
the same number twice, then just ignore it and do it again.
Okay.
Yeah, because you want 10 different seats, 10 different people. Yes. Another notes packet? Yeah. Do you need another homework assignment too? Okay, sorry. Grab just the back packet. We're on page 7. All right. If you're still working on getting your 10 seats selected, that's fine. I am going to go ahead and start giving directions for the next one so that we can pick out our next sample. All right. we're going to use a second method here. We're going to randomly choose 2 fans from each horizontal row. If we choose 2 fans from each row, how many are we going to end up with total? We're going to end up with 10 total, right? So you need to label your columns 1 through 10, label your rows 1 through 5. So now you would want your random number generator. Oh, we're on the second one now. Second one down, method 2. There you go. Now you would want your random number generator to go from what to what? Still want it to go up to 50? 1 through 10. Use a random number generator to select 2 random numbers for each of these rows. We're on method number 2 now, so the next one down, number 2. So you need to label your columns and your rows.
Yeah.
You're going to pick 2 from every horizontal row. How many seats are in each row? 10. So you're going to use your random number generator to pick out 2 numbers between 1 and 10. And then you'll do that again for the second row. And then you'll do that again for the third row, again for the fourth row, and again for the fifth row.
Do I just turn them on?
Yeah. So you're going to select the people in the first row, and then you're going to repeat the steps to select the people in the second row, and then repeat the steps to select the people in the third, fourth, and fifth rows. Mark the people that are getting chosen. This method that we're doing right here underneath number 2, this is called stratified random sampling, where the strata are the rows. We've broken them up into strata. That's the smaller groups that we have. And then we're selecting some of our sample from each of those strata here. Why might the concert promoter decide to do it this way rather than the way we did the first time? What'd you say? Good question. What do you mean by more randomized? I like it.
You don't know what seats there. Is this more specific?
So I want you to think about yourself at the concert. Like, do you think somebody in the front row has a different experience than somebody in like the 10th row or the 50th row?
Like real fans, dedicated fans in the front.
Yeah. So, I mean, even just the concert experience itself, maybe there's some things that you can't see if you're out on one of the edges, or that you can only really appreciate if you're dead center or if you're in the front row. If they have pyrotechnics, they throw out confetti or whatever, you're going to get it in certain rows and not get it in other rows. So it would change your experience from the concert. So after you have selected these 10 seats, I want you to do the same type of thing for number 3, but instead of the rows being the strata, I want you to do it with the columns being the strata. How many seats are there in each column? 5 seats in each column. So how many seats should you choose in each column if you want to end up with 10 people total? 10? 1 from each column. So use your random number generator. Go from 1 to 5 this time, because you want 1 seat in each column. So you should have a total of 3 different random samples. Pike them just a couple minutes to finish choosing their random samples, and then I want to talk about which of these three methods you think would be the best. And I want you to think about why. So if you're all the way done, I want you to look at the way your sample is distributed throughout this section of the theater. Tell me which way you think would be the best way for the concert promoter to take his sample. For the time being, the most important thing is that you're getting your random sample selected. I can put the text up on the screen for you guys to get copied down, but if you don't have your random sample picked out yet, you absolutely need to do that next. Okay, so for this one, you're doing one from each column.
Okay.
This one here, you should have two in each row. Yeah, this one you should have one in each column. You should only have one seat in each column for this. One seat from each vertical column. So one here, one here, one here. On this one you need two here, two here, two here, two here, and two here.
So I did this wrong.
No. This one, you've got your 10 selected here.
Yeah.
For this one down here,
Just two in each.
two in each row. For this one down here, you're going to do one in each column.
So I did like I got 4 and 9. That's
Okay.
it. And then I keep going.
And then you do it for this row now. So you get two more new random numbers for your second row.
Okay. And then here is just one in each.
One in each. So you'll pick a number 1 through 5 and mark that person, and you move over to the next column. Yep.
Thank you.
You're welcome. You might want to mark in here which ones got selected so you can kind of see it. Of these three ways, I want you to look at the way it's distributed. Which of these three methods do you guys think is the best? First one, second one, or third one? You like the third one best? Second one?
Can the numbers repeat?
From row to row, yes. But like if you're doing row number 1 and it gives you 5 both times, because you need 2 different seats in each row, yes. All right, so second or third one, those of you that are telling me either number 2 or number 3, why? It's the most spread out. I like it. And depending on the random numbers that you chose, 2 might be more spread out on yours, 3 might be more spread out on somebody else's, depending on the random numbers that you had there. We want good overall coverage. We want good representation of these 50 seats. So you could go with number 3 or number 2, depending on what it looks like on your page. So again, this is called stratified random sampling, where we divided up our original population into these groups. In this case, we did groups by row, and then we also did groups by column. And then we selected a couple from each of those sections. When we do stratified sampling, we're going to choose strata based on characteristics that might affect people's responses. So for example, if I wanted to know what people in Pike Township think of going to a completely balanced year-round calendar, and I send this survey out, do you think that students might have overall generally different responses than parents would? So I might want to make strata between parents and students. I might even want a third strata that's like people that are adults in the community, but they don't have kids, or their kids don't go to Pike schools. They might have a very different opinion than what Pike parents think and what Pike students think. So if I think that a particular group or groups are going to have different answers to things, I want to make sure that I get some opinions from each of those different groups. And so that's how I would set up my strata. All right. We are actually going to calculate the overall enjoyment level for the 3 different samples that you selected. And for people that are still needing to get some of the text that I have up here, I'll go back and put it up. But let me show you what you need to do next. So back here, these are the ratings that all 50 people gave on a scale of 1 to 100. How much they enjoyed the show. For sample number 1, the seats that you selected, I want you to find what those scores were, add those 10 numbers together, divide by 10. And then I want you to do the same thing for sample number 2. Find where those seats were, add those 10 numbers together, divide by 10. Do the same thing for the third method. So I want you to have the averages for all 3 of your samples. Sarah, I brought that back up if you want to snap a picture of it. So I want you to calculate the average enjoyment for each of these samples. Add them up and divide by 10 for your seats. And you're getting the numbers from what's on the back side, not the seat number. You flip this paper over. These are the scores that we're getting. These are the numbers that you're going to add up that correspond to these. So like seat number 41, that person gave it a 61. Seat number 21, they gave it an 80. At 80 and 69, and then these 3 seats, you want all 10 of the seats that you selected. Find them over here, and add those 10 numbers together. Is there anybody that is confused about how you're finding the numbers to add together? Because again, I don't want you adding seat numbers. Once you have your average for method number 1, I'm going to give you guys a little green dot over here. This poster right here that says SRS, Simple Random Sample, that was our first method. You're going to come and add your dot to this poster right here for method number 1. So once you have your average, take the green sticker that I'm passing out, add your dot to that first graph that says SRS, Simple Random Sample. And right now we're just doing method number 1. Method number 1 is your Simple Random Sample. You'll put the green sticker on that one over there, the first one where it says SRS. After you put your dot up on the Simple Random Sample, I want you guys to calculate the average for method number 2, where we stratified by row. I want you to calculate the average again. Once you're done with method number 1, then I want you to calculate the average for method number 2, stratifying by row. That's going to go on the middle poster with a red dot. Okay, just wanted to make sure I'm not taking out red ones unless there's any ones that go. Yep, you're just doing the green one. Then the red one. Red dot middle poster, method 2. What'd you say? I'd put it closer to that number, yeah. You're going to use the same numbers here that you're looking down to where that is. So you're looking at these. You want one on each of these, so you should have one seed here. You have one seed here, so it looks like you want this way. You have one seed in this one.
She said that it burnt because of
Who does not have a red dot yet? Is there anybody else that I have not given a red dot to yet? All right. For method number 3, these are going to be blue dots on the last poster. So if you haven't already calculated that one, please go ahead and calculate method number 3.
Yeah.
Blue dot on the last poster for method 3. Third one, third. Who have I not given a blue dot to yet? I'm missing somebody. I don't know who I missed. Yes. I want you guys to get sketches of these in your notes. You need to get sketches of these into your notes. That's okay. I calculated.
Yeah, because I was just like,
Who did I miss for the blue dot? Somebody doesn't have a blue dot yet. Let me say that. Make sure you get sketches of these guys into your notes, please. So I want you to be able to look back at these. I'll leave the posters up for a couple of days, but eventually we'll run out of room. And I'll have to take them down. I'm curious what you guys think of these. I'm going to come and mark where the true mean is. So if we had added all 50 of those numbers and divided by 50, the true mean is 78.38. True mean is 78.38. So I'm curious about your opinion of our three distributions. Individually, you might have seen that method 2 was more spread out or method 3 was more spread out. Looking at it like this, which of those three methods did the best job of helping us get closest to the true mean? Which method got the closest to the true mean? Number 2 is what it looks like to me. So when we talk about whether it has high bias or low bias would mean the center of the distribution is near what the true mean is. What do you guys think about these? The true mean, is it about in the middle of all three distributions? Close-ish? I would say on our simple random sample, here's the true mean. We've got 1, 2, 3, 4, 5, 6 dots over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not exactly halfway, but it's split almost in half side to side. I would say that this graph over here has low bias. Again, low bias means that the mean of my distribution, the middle, the center, is about approximately where the true mean is. Kind of split half and half on either side. What do you guys feel about the middle one? Low bias or high bias? Low bias. it's low bias to me, right? Both of the ones that we did on Friday, were those both low bias? Were either of them low bias on Friday? Were either of them low bias? Or if you had to pick one that was lower versus higher, which one of the two that we did on Friday had the higher bias? Convenience sample. Here's the true mean, which is nowhere near the center of our data. So this one has high bias. In comparison, this one over here has lower bias, right? So all three of the ones that we did today have pretty low bias. The center of the data is about where the mean is. What's the biggest difference that you see as you look at these three distributions? Which one stands out? Yeah.
The second one is really excellent. Like there's not much there.
Yeah, that middle one. Do you guys see how it's all very tightly packed around that mean? We would say it has low variability. This one has the lowest variability. It's not very spread out to the left and to the right of the mean. So of these three methods, which one would give the concert promoter the most reliable average? Second option. Now that might not have been true for your specific sample, but as we do a sample and 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 we put all those together, that's when we see that this second one did the best. Why do you think that would be? Like, I want you to think about the way this was laid out. This was stratified by what? Stratified by row. People in the first row generally, do you think, had a better time or worse time than people in the fifth row? Probably had a better time. They paid for those front row tickets. They paid a lot of money to see Taylor front row. I wouldn't say that any of these three is a bad method, but I would say there is a best method up here. Does that make sense? So we've talked about two different types of sampling methods so far. We talked about simple random sample. We did that Friday and we did that today. And then we've talked about stratified sampling. And there's lots of ways that you can do stratified sampling. One of the ways that's falling out of popularity now, but still gets used sometimes, is stratifying by gender. If you think that in this particular situation, people who identify as male are going to have different responses overall than people that identify as female, you would want to have those strata. So maybe there's, identifies as male, identifies as female, identifies as non-binary. You would now have 3 strata instead of just 2. But you'd want to make sure to get people from each of those groups. Usually, although not always, when you do stratified sampling, you want to make sure that whatever population size, let me see if I can put this right. If the group that you're looking at, say we're doing male, female, non-binary, and in the group that you have, about half the people identify as male, about 30% of the people identify as female, and about 20% of the people identify as non-binary. Then when you do your sampling by strata, you'd want to make sure that overall, about half of the people are coming from the group that identifies as male, about 30% of the people are coming from the group that identifies as female, and 20 from the non-binary group, so that it accurately reflects your larger group. Does that make sense? All right, cool. Let's look at big ideas for today. So simple random samples we've talked about. Choosing a group from the population so that every individual and group of individuals is equally likely to be chosen. And our steps for simple random sample: label, randomize, select. I will tell you, last year on the AP exam, there was one situation where students were asked to describe how they would select a random sample. And a lot of students said that they would write down the participants' names on slips of paper, which is fine, but then they left out a key step that went from an E to a P. When they talked about putting all those slips in a bowl or in a hat, They left out the part where they would mix them all up. That's the randomizing, and that's really important. If you just put them all in a hat and then you draw out, you're going to grab off the top. That's not a random order. Those are the people that you put in last. So you want to make sure that you talk about mixing them up or using a random number generator there. And then you select. Stratified random sampling splits the population or the groups into strata, and then you choose a simple random sample from each of those strata. Cluster sampling, which we did not model yet, but we will. Cluster sampling splits the population into groups based on location. So if I was going to do cluster random sampling like here at the high school, my clusters might be classrooms. Everybody's all there together in the same general location, and I'm going to go in and I'm going to ask everybody in that class my survey question. I'm going to record that data. Then I'm going to leave. I'm going to go to a different classroom that was randomly selected, but this way I only have to visit so many classrooms instead of going to each classroom and talking to 2 students from each class. So you split your population into groups based on location. You randomly select the groups and you sample everyone in those selected groups. So if we were to do cluster random sampling in this example, that would be like choosing rows as our clusters, because they are the same general location to each other, and then randomly choosing 2 of those clusters and taking all 10 people from each of those rows and not getting the opinions of anybody else. Pluses and minuses to cluster random sampling. Cluster random sampling usually ends up being very time efficient. You can get a lot of responses without a lot of time or a lot of money spent. But it doesn't tend to be as accurate in predicting as, say, stratified random sampling is. I want you guys to take a minute, look down at the check your understanding. We'll go over this tomorrow, but I want you guys to get started on it now. Describe how to select a stratified random sample of 36 people hired by ETS to score the AP Stats exam. And I want you to explain the choice of strata. So they've given you a situation up at the top. I want you to read through that and then describe how you would use stratified random sampling there. Yes, you can. While you guys are finishing this up before the bell, I wanted to let you know, yes, tests are graded. Grades are up in Skyward and in Canvas if you want to see them. I don't have time today to pass them back, but I will make sure to leave time tomorrow to pass them back so that you can see them. But if you want to know just your score, you can hop into Canvas or Skyward to see your score. Don't forget homework 4.1 is due on Thursday of this week. We'll finish doing the check your understanding right at the beginning of class tomorrow. And then we'll go on and look at the next piece.